Good afternoon, everyone. So today we are going to start a networking lesson, that is Unit 6 lesson of the grade 12 syllabus, right? So this is very important lesson, and definitely you are getting essay type question from this part and some MCQs also, right? So I think you all got that with you, right? So I will start. I will share the tube with you. Okay. The data communication and networking, we have two different types of signals, right? So the one is analog and one is digital. Now, if I talk about this analog and digital, if you take analog signal, you have continuous values. As example, now suppose here 5 volt, here 0, right? So what will happen in between? You can take different values. So that is called continuous data, right? Now, when you take the digital signal, that is, you have only 1 or 0. That is when you are drawing the signal like this. Suppose if it is 5 volt, this is 0. We are representing 5 volt as 1, 0 as 0. So 1 or 0. Two different values are there for the digital signal. When you take the analog signal, you have continuous data, continuous wave. So we can have different values. Different values, right? So I will share the tube with you. Analog signal and digital signal. Under analog signal, write down. On the analog signal, write down. Analog signals are in continuous wave. Analog signals are in continuous waveform. In nature, and represented by continuous electromagnetic waves. Continuous electromagnetic waves. So when you take the digital signal, you can see digital signals are discrete in nature and represent sequence of voltage pulses. Digital signals are used within the circuitry of computer system. Right now, analog signals. Now in our body, even we have analog signals, right? So analog signal, when you take a pressure meters, thermometer, now we have digital meters also, right? So those are having analog signals, analog data tama egola use karate, right? So then we'll see the properties of these signals. First one is amplitude. Amplitude means actually the height of the signal. Now you can see here, height of the signal is called amplitude. Under that, write down under amplitude. Amplitude is the height of the wave. Amplitude is the height of the wave and often related to power. Often related to power. Often related to power. Then look at the frequency. The frequency of the wave is the number of waves that pass by each second. When you take a second, if you have that, you can highlight that part. So when you take a second, how many waves is passing, right? And it's measured in hertz. Suppose a wave repeats itself 3 times each second, then we say frequency of that wave is 3 hertz. And then this is 3 hertz. එක සෙකන්ඩයක් කියලා අපි අරගත්තොත් මේ සෙකන්ඩ් එකේදී පාස් වෙන waves ගන්න, right? So here you can see 6, here you can see 12. right? So it is next with the next point you are getting the wavelength, then you can understand better. Wavelength lambda is the physical length from the one point of a wave to the same point of the next. That means if you are starting from here up to here, right? That is the wavelength. Long wavelength, if you have long wavelength, low frequency. Now here, low frequency. Short wavelength, high frequency, right? Frequency, that means number of waves. Waves gana tappareke තියෙන waves gana වැඩි if it has short wavelength. Wavelength එක අඩුයි නම්. ඒ කියන්නේ frequency එක වැඩි වෙනවා. If you have long wavelength, frequency is less. That is අඩුයි. Low frequency and long wavelength එකක් ආවොත් එහෙම, right? So these are the theory things you have to memorize this stuff, right? Then pace. Pace means definition of the position of a point in time. Now we are calling it as angle. Then මෙතන පටන් ගන්න angle එකයි මෙතන එකයි වෙනස්, right? එතකොට මේ angle එකෙන් තමයි මේ pace කියන property එක හැදිලා තියෙන්නේ. Pace is a definition of a position of a point in time instant on a waveform cycle. A complete cycle is defined in the 360 degree of phase. සම්පූර්ණ එකක් කියන්නේ ඒක සම්පූර්ණයෙන්ම එනවා කියන්නේ දැන් මෙතන පටන් ගත්තොත් මෙතන ඉඳන් ආපහු මෙන්න මෙතනට එනකන්, that is the complete cycle. It has 360 degrees. Degrees ගාන ඒ සම්පූර්ණ එක බැලුවොත් එහෙම අපේ angles ටික add කරොත් එහෙම you get 360 කියලා අපි කියන. That is called pace. So those are the properties of the signal, right? Then there's something called propagation speed in media. Propagation speed. Under that, write down propagation speed කියන එක ඇත්තටම මේක it's related to media. Media එකට තමයි මේක related වෙන්නේ. Under that, write down the speed the speed at which a wave propagates, the speed at which a wave propagates through a given medium, the propagation speed also varies from medium to medium, depending on the properties of the medium. Depending on the properties of the medium. Depending on the properties of the medium. Right? So there are two different media. I will explain that. So we have two different medias. Guided media. Other one is unguided. So these are the two medias, right? So data transfer කරන්න පුළුවන්, data transmit කරන්න පුළුවන් medias දෙකක් තමයි මේ දෙක, right? Then when you get guided media means cables that you can touch them. අපි කියනවා physical media, you can touch them. Different types of cables are there. අපි ගන්නවා coaxial cable, twisted pair wire, fiber optics. I will show them. So අපි මේවට කියනවා cables. Those are called guided media that you can touch them, right? Then unguided media means that you can't touch. These unguided medias are used air. වාතය තමයි අපි පාවිච්චි කරන්නේ to transmit the data, right? So those are called radio waves, microwaves, infrared, Bluetooth. Those stuffs are coming under unguided media, right? So these are the two different media we are using to transmit data, right? We go to the tutor again. Okay, now look at here. Guided media. Wire is the physical medium used to transfer data from one network device to another. Wires are often called guided media because they guide the data transfer data from one point to another without altering the frequencies. Data impairment are therefore reduced. That means the signals are going through the cables, right? So environmental problems are not much affected to the system, right? Examples of guided media: twisted pair, UTP and STP, coaxial cable, fiber optic cable, right? Now you can see here, when you take the twisted pair wire, two different twisted pair wire. Then when you make it put the coat එකක්, that is aluminium kind of a coat is there. මේකේ coat එක නැහැ, right? මේකට කියන්නේ අපි shield twisted pair. Shield එක තමයි අර coating එක. Because of the coating එක නිසා මොකද වෙලා තියෙන්නේ? අපේ අර එළියෙන් එන effect එක අඩු වෙලා තියෙනවා. Data transmit වෙද්දී එළියෙන් effect එක, as example, you are trailing these wires through magnetic field. Magnetic field එක අතරින් මේක ඇදගෙන ගියා කියන්නේ මේ wire එක. එතකොට data transmit වෙද්දී මොකද වෙන්නේ? මේ මේකෙන් data යද්දී ටිකක් බලපෑම අඩු වෙනවා other than the UTP. UTP එකට තරම් බලපෑමක් ඇති කරන්නේ නැහැ, right? එතකොට අපේ සාමාන්‍ය STP එකක් අපි කියනවා around 150 වගේ meters ඇදගෙන යන්න පුළුවන් නම් අරක 50 or 100 meters තමයි UTP එකේ data ගෙනියන්න පුළුවන් කියලා without any effect, right? But still if you get go through the අපි හිතමු magnetic media එකක් කරහා වාරයක් ඇදලා තියෙනවා කියලා, so data can be damaged. Data damage වෙන්න පුළුවන්, right? Okay, then unguided media is there under this one. This is called coaxial cable. අපි දැකලා තියෙනවා, you can see in the antenna wires වල දකින්නේ මේ වගේ cable එකක්. And this is fiber optic cable, right? So fiber optics, they are using light reflection. මේ ටෙක්නොලොජි එක තමයි මේක පාවිච්චි කරන්නේ. අපි අර ආලෝක පරාවර්තනය කියන එක පාවිච්චි කරලා තමයි data transfer කරන්නේ. So therefore its speed is higher than the other cables, right? I think speed එක වැඩිම මේකත් එක්ක තමයි කියලා අපි කියන්නේ. Okay, then unguided media එකට අපි යමු. Write down on the unguided media. Signals are spread. Signals are spread into the air. And data can spread to any direction. And data can spread to any direction. Examples for wireless communication. Examples for wireless communication include radio transmissions. Satellite transmissions, and infrared. Right? So you get radio transmissions, satellite to transmit data through the satellite. You have to have the direction should be straight line should be there. They are transmitting data like that way. So the කෙලින් තියෙන්න ඕනේ නැත්නම් යන්නේ නැහැ. This radio transmission can be divided to Wi-Fi, Bluetooth කියන ඒවා දෙකම එන්නේ radio transmission වලට. Other than that, අපි infrared කියලා ගන්න ඔය මේ what's called remote controls වල එහෙම තියෙන්නේ. So that is called infrared. So ඒක ගොඩක් දුරට යන්නේ නැහැ data. පොඩි දුරක් යන්නේ ඔය TV remote වගේ දේවල් that is called infrared. So those are used air. වාතය හරහා තමයි data transmit කරන්නේ. That's why they are called unguided media. Unguided media කියලා කියන්නේ ඒකයි. Then properties, we'll go through the properties of these media. Latency. Network latency is an expression of how much time it takes for a unit of data, right? Which are kata karno frames, data packets ke gaya. So that can be a unit. Ek thamai unit tag kiyala kiyanne. Api gaththot measurement unit තියෙන්නේ අපි දැන් kilogram, gram ඒ වගේ data transmission also you can get some units, right? So how much time it take for a unit of data to travel from one point to another. A point එකකින්ද තව point එකකට යන්න. Latency is usually measured in millisecond. Millisecond වලින් තමයි. Then bandwidth. Bandwidth is a range of frequencies and measured in hertz. Bandwidth එක අපි දන්නවා low bandwidth, high bandwidth. Bandwidth, if the bandwidth is high නම් we can have several frequencies. නැත්නම් එක types data අපිට ගොඩක් යවන්න පුළුවන් if the bandwidth is high. කියන්නේ නිකන් අපි හිතනවා it's like the width. අපිට දැන් පාරක් තියෙනවා නම් පොඩි පාරකට අපිට වාහනයකට යන්න බැන්නාට ලොකු පාරක වාහන දෙක තුනක් යන්න පුළුවන්. Something like that, right? So bandwidth. Then noise. Noise is received signal that makes no sense. That means sometimes when you are now I am teaching from here, so my signals are coming through the cables or whatever you have connected through the whatever the media, and you can see them. But if there's a noise and all that, my data and the noise both will be added together and transmitted. Right? Then attenuation. Attenuation is a reduction of the signal energy as it travels through a given medium. When you are transmitting data, sometimes it won't go much longer. ඒක තමයි අපි ඉස්සෙල්ලා කතා කරේ STP and UTP cables ගත්තාම UTP එකට වඩා STP එක දුර යනවා වැඩි, right? So that is attenuation. So attenuation එකක් තියෙනවා කියන්නේ that reduction of the signal energy. Energy එක නෑ. ඒක එයාට යන්න බෑ එච්චර දුර, right? It will damage or it will stop, right? Data එක transmit වෙන්නේ නෑ if you get the attenuation, right? Then distortion. Distortion is alternation or distort of properties of transferred signal caused by the capacitance and inductance of the communication medium. So medium එකේ තියෙන අපි ගත්තොත් එහෙම resistance එක capacitance එකත් එක්ක ගත්තොත් එහෙම your signal won't, that is also same අර වගේම attenuation වගේම යා signal එක it can't go further. එයාට දුර යන්න බෑ, right? So that is called distortion. It can be changed. Change වෙලා අපිට යන එක නෙවෙයි වෙන එකක් තමයි අපිට එන්නේ, right? Now look at this picture. If you get signal and noise, then you are getting something like this. This is what you are getting, signal එක. එතකොට අපේ ඇත්තම signal එක මේක එවන්න ඕනේ, right? ඒතර මේ වගේ වෙනස් වෙන්න පුළුවන්. That kind of things are there. So these are the properties, right? Then we'll go to the modulation. So modulation ගත්තොත් එහෙම now you have different types of modulations available. Modulation means now something like this. මම කියන ඔයගලන්ට පොඩි lens එකක් දීලා කියලා මේක විසි කරන්න පුළුවන් තරම් ඈතට කියලා, right? So you are trying to throw it as much as possible, but it won't go much distance නේද? ඒක යන්නේ නැහැ because of the wind and all that. ඒක අනිවාර්යයෙන්ම නවතිනවා ටිකක් දුර ගිහිල්ලා පාවෙලා වගේ ගිහිනවා, right? But if you put a stone on that, ඒක ගලක් මොකක් හරි ඔතනවා. ඔතලා දැන් විසි කරනවා, right? So it is definitely going more distance than the earlier one. ඉතින් ඔන්න වගේ technique එකක් තමයි modulation කියලා කියන්නේ, right? So when you are doing the modulation, you have the carrier signal and you have the data signal. So the data signal එකයි carrier signal එකයි දෙක එකට එකතු කරලා you are transmitting. So අපේ purpose එක ගොඩක් වෙලාට මේව කරන්න to transmit our data more distance. ගොඩක් දුර යවන්න තමයි අපි මේ technique එක use කරන්නේ, right? So this is modulation. Now we know we have different properties, frequencies, phase, amplitude වගේ ඒවා අපි ඉස්සර දැන් ඉගෙන ගත්තා. එතකොට ඒව වෙනස් කරලා තමයි modulations හැදිලා තියෙන්නේ, right? So modulation, even analog modulation, digital modulation, both are there. අපි ඉතින් ඒවා ගැන දැන් කතා කරන්න යමු එහෙමනම්. Okay. දැන් මේකේ පෙන්නලා තියෙන analog modulation එකක්, analog modulations. First one, amplitude modulation. Then මේ amplitude modulation එකේදී what is happening, you have the carrier wave එක තියෙනවා, ඔයාගේ data wave එක තියෙනවා, ওই දෙක එකට එකතු වෙලා this is the new signal you are transmitting. එතකොට මේ දෙකේ එකතුවක් විදිහට තමයි මේක යන්නේ. Here we are changing only the amplitude. That means frequency and the phase is not changing. එතකොට මේකේ amplitude එක විතරක් change කරලා data එක transmit කරන නිසා අපි ඒකට කියනවා amplitude modulation කියලා, right? So we'll write down under amplitude modulation. අපි ලියා ගමු. Write down. In this modulation, the amplitude of the carrier signal is modified to reflect the analog data. මේක එකයි ඔයගොල්ලෝ print කරලා දුන්නේ මේ ඔක අඳින්න ගියොත් එහෙම පොඩ්ඩක් අමාරු වෙන නිසා. Then look at frequency modulation. Frequency modulation එකේ දෙලා තියෙනවා. Carrier signal and the data signal is there, but it is changing the frequency. Frequency එක change කළා තමයි මෙතන modulation එක හැදිලා තියෙන්නේ. So in this modulation technique, the frequency of the carrier signal is modified. Frequency එක තමයි carrier signal එකෙන් change වෙන්නේ. It's modified to reflect the change in the voltage level of the modulating signal. Analog data එක හදා ගන්න. Then we'll go to phase modulation. The phase modulation, what is happening? You have the carrier signal and modulating that is data, but here phase is changing. When phase change වෙලා තමයි මෙන්න මේ signal එක හැදිලා තියෙන්නේ, right? So that is called phase modulation. That means frequency and the amplitude is not changed. ඒ දෙක change කරගන්නේ නැහැ. So in the modulation technique, the phase of the carrier signal is modulated in order to reflect the change in voltage amplitude of analog data signal, right? Okay, then we'll go to the digital modulation. Okay, so here digital modulation means now we have digital signal. Then my digital signal එකක් තමයි ඈතට යවා ගන්න. Right? So here what we are doing actually, අපි මේ digital signal එක analog එකකට convert කරලා තමයි යවන්නේ. So that modulation is known as shift key. මේකට අපි කියන නම modulation කියන නම පාවිච්චි කරන්නේ නැතුව shift key කියන එක තමයි අපි digital modulation වලදී use කරන word එක. So in a digital modulation, amplitude shift key means you are changing the amplitude and phase and the frequency will be keeping as same, right? So under amplitude shift key, write down. Now you can see the signal. Digital signal is there. ඒක තමයි මේ convert කරන්නේ analog signal එකකට. මෙතනදී ඒක තමයි අපේ transmit කරන්න, right? So there write down amplitude shift gain. In this conversion technique, the amplitude of analog carrier signal is modified to reflect binary data. Okay. Then we'll see phase shift key. So in this conversion scheme, the pace of the original carrier signal is altered to reflect the binary data. එහෙනම් එතනදී මොකද කරන්නේ? Phase එක change කරලා තමයි signal එක හදාගන්නේ, analog signal එක according to the digital signal. Then you have frequency shift key. There, in this conversion technique, the frequency of the analog carrier signal is modified to reflect the binary data. ඒකෙදි මොකද කරන්නේ? එහෙමනම් frequency එක change කරලා තමයි data එක හදාගන්නේ. ඕ analog signal එක generate වෙන්නේ according to the digital data. Right? Then you have another thing called analog to digital conversion. දැන් අපි කතා කරා analog එකක්ම modulate කරලා analog එකක් විදිහට යවන්න. digital එකක් analog කරලත් යවන්න. එහෙමනම් analog එකක් digital කරන්නත් පුළුවන්. Right? So analog to digital conversion most of the time. Then බලන්න අපි as example, if we take our body, when you take a ECG machine or something like that, ECG machine එකක් ගත්තොත්, so we have analog data in our heart. එතකොට මේ this analog signal is taken through this ECG machine and converted into digital, and it is showing through that monitor එකේ අපේ දැන්, because the computer can understand on digital data, that is ones and zeros, right? So that is converted, that is analog to digital conversion is happening there. නේද? ඒ වගේ අපිට වෙන්න පුළුවන් analog and digital data conversion can happen, right? So we'll go through that one. Microphone create analog voice and camera creates analog videos which are treated as analog data. To transmit this analog data over digital signal, we need analog to digital conversion. So analog data is continuous stream of data in the waveform, whereas digital data is discrete, that we discuss. What is analog, what is digital? To convert analog wave into digital data, we use pulse code modulation. If you have a highlighter, please highlight this one. Pulse code modulation PCM method එක තමයි අපි use කරන්නේ analog to digital conversion වලට. Then PCM is one of the most commonly used method to convert analog data into digital form. Right? Now here it involves 3 steps: sampling, quantization, encoding. මෙන්න මේ ක්‍රම තුන පාවිච්චි කළා තමයි analog to digital conversion is happen, right? So we'll go to that part. Sampling. The analog signal is sampled every t interval. Now you don't want to worry about this stuff. You just want to know what is the method you are using, but these are additional stuff for you all, right? So sampling means the analog signal is sampled every t interval. දැන් මෙතන බලන්න diagram sampling එක, that means every t interval. We don't know actually time interval කීයද කියලා. අපි තප්පරෙන් තප්පරේ, නැත්නම් තප්පර දෙකෙන් දෙක, නැත්නම් මිලිසෙකන්ඩ් එකෙන් මිලිසෙකන්ඩ් එක, මොකක් හරි method එකක් use කරලා මේක sample කරගන්න, right? කෑල්ල කෑල්ල මේක වෙන් කරගන්න එකයි මෙතන කියන්නේ sampling කියලා. The analog signal is sampled every t interval. Most important factor is sampling is that rate is which analog signal is sampled according to the Nyquist theorem. There's something called Nyquist theorem. Don't worry about them. The sampling rate must be at least 2 times of the highest frequency of the signal. So මේ sampling කරන එක තමයි මුලින්ම that take that idea sampling කරන එක කරනවා. Then after sampling quantization කියන්නේ we are giving අපි හිතමු මොකක් හරි මෙන්න මේ ගානට වඩා වැඩි ඒවා හරි නැත්නම් අඩු ඒවා හරි කියලා අපි පොඩ්ඩක් වෙන් කරගන්නවා. මෙන්න දාන sampling yield discrete from continuous analog signal. Every discrete pattern shows the amplitude of the analog signal at the instance. Amplitude එක තමයි පෙන්නන්නේ. The quantization is done between the maximum amplitude value and the minimum amplitude value. Quantization is approximation of the instances analog values. එතකොට මේ දැන් මෙතන මේ විදිහට අපි දැන් මෙතනින් අපි මෙන්න මෙතනින් එන values ටික තමයි ওই ටික තමයි මේ විදිහට quantization කරගෙන තියෙන්නේ. එතකොට minimum and maximum value එක බලලා තමයි ඒ calculation එකට තමයි ඒක හදාගන්නේ. Then encoding each approximated value is then converted into binary format. එතකොට අපි ඒකෙදිත් ඒගොල්ල use කරන්නේ mathematical method එකක්. එතකොට මේකෙත් according to values මෙතනින් මොකද්ද represent වෙන්නේ 1ද 0ද මෙතනින් මොකද්ද 1ද 0ද එහෙම කියලා මෙන්න මේ encoding part එක ඇවිල්ලා we are getting the digital signal. This is called digital. So ones and zeros means it's digital. So this analog has become the digital by using this PCM method, right? Okay, then we'll go to the encoding part. Right, encoding. So this explains how to convert digital data into digital signals. So then we have the digital data with us. Ones and zeros කියලා දෙනවා. හැබැයි it should be converted to a signal. එක signal එකකට convert වුණාට පස්සේ තමයි we can transmit this data. The data is transmitted as a signal. අපි at the very first page we discussed what is the two different types of signals, analog digital කියන එකත් කතා කරා. ඉතින් මේ විදිහට signal එකකට convert කරගන්න එක අනිවාර්යයෙන්ම වෙන්න ඕනේ මෙතනදී, right? So it can be done in two ways, line coding and block coding. For all communication, line coding is necessary, whereas block coding is optional. ඒතර අපි line coding කියන එකේ තියෙන syllabus එකේ තියෙන 3 methods ටික තමයි අපි ඉගෙන ගන්න, right? Now here non-zero to return level is an encoding scheme in which two different voltage for 0 and 1 bits are used to represent data and remaining constant during bit interval. එතකොට ඒකේ බලන්න පොඩ්ඩක් diagram එක 0 පල්ලෙහාට යනවා 1 උඩට එනවා ආයි 0 පල්ලෙහා 1 උඩ ඔය විදිහට 1 1 උඩ ඔය විදිහට අපිට අදින්න පුළුවන්. Other than that we can draw like this even. අපිට මෙහෙමත් අදින්න පුළුවන් ඕක NRZ del කියන එක NRZ del. Suppose these are our values කියලා හිතන්නකෝ. So 1 you can represent like this. 0 පල්ලෙහාට ආවා. Again 1, again 1, 0, 0, again 1, right? So this is possible. මේ පල්ලෙහාට අපි minus values වලට ගන්න නැතුව axis එක we can draw like this even, right? So in the tune the aside the මේකේ එහා පැත්තේ side එකේ වෙද්දී මේකත් චුට්ටක් ඇඳ ගන්න, right? This is also possible. No need to take the minus value or x axis එක පල්ලෙහාට යන්න නැතුව අපිට මේ විදිහට ගන්න පුළුවන් කියන එක එතනම චුට්ටක් ඇඳ ගන්න for this data මේ data එක දාගන්න ඉක්මනට. Okay. Then we'll see NR reset I. NR reset I. So that is called non-return to zero inverted. Now look at here. Make a signal like a මෙහෙමයි. 0 පල්ලෙහා value එකකින් 1 ආපු ගමන් උඩට හරි කොහේ හරි යනවා. That means එක්කෝ 1 ආවොත් උඩට එහෙම නැත්නම් පල්ලෙහාට. That means it is changing the level. Level එක change කරනවා. එයා ඉන්නේ උඩ නම් පල්ලෙහාට එනවා, පල්ලෙහා ඉන්න උඩට යනවා. But if you get 0, nothing will happen. I 1 ආපු ගමන් මේ පල්ලෙහාට ගියා. ඔහොම යනවා. I 0 ආවට මුකුත් වෙන්නේ නැහැ. ඕන්න 1 ආවම I උඩට ගියා. 1 ආවම I යට ගියා. So it is change. 0 ආව කියලා මුකුත් වෙන්නේ නැහැ. 1 ආවම එතනට ගියා, right? So same thing I will show you by using the like the earlier one. Selaw එකකට පෙන්නන්න එක. Same data. මේ data එක මම ගන්නවා. එහෙනම් අපි මේක පල්ලෙහාට යන්න නැතුව අපිට අඳින්න පුළුවන්. 1 I will take here. 0 nisa make nothing will happen because when you get the 0 it is not changing. You know 0 guna kiyala make ehimamai. Because of 1 it is going down. Onne 1 I මේ 1 එක නිසා මොකද වෙන්නේ? I එක උඩට එනවා. එයා ඉන්න තැනින් වෙනස් වෙනවා. It can be go up or up and down. ඒ කියන්නේ up and down යන්න පුළුවන්. එයා ඉන්න තැනින් ඉඳන් අනිවාර්යයෙන්ම change වෙන්න ඕනේ if you get 1. Then here because of 0 nothing will happen. මේ 0 එකකට මොකුත් වෙන්නේ නැහැ. මේ 0 එකකට මොකද? Because of last one I am පල්ලෙහාට. So this is called NR reset I. එක චුට්ටක් දාගන්න ටියුට් එකේම එහා පැත්තේ. Okay, then we'll see Manchester encoding. Manchester encoding voltage change from low to high or high to low in the middle of signal. Signal එකේ මැදදී තමයි change වෙන්නේ. then මෙන්න මේ විදිහට අපි Z එක අකුරක් වගේ මේක Z නෙවෙයි. It is representing 0. මේක නිකන් S අකුරක් වගේ. It is representing 1. එහෙනම් මෙතන 0 ආව ගමන් it is changing the middle. මේ බලන්න. signal එකේ මැදදී තමයි ඔයගොල්ලෝ අදින්නේ මේ පල්ලෙහාට. පල්ලෙහාට ගිහිල්ලා මෙන්න change වුණා. දැන් 1 එක I මේ මැදදී change වෙලා උඩට ආවා. I0 එක IZ එක ඔය විදිහට ඕම ඇඳ. I0 එක IZ එක ඔය විදිහට ඇඳ. ඔය විදිහට ඇඳගෙන යන්න තියෙන in the middle you have to change. ඊට පස්සේ මේ වගේ ඒවා connect කරන්න you can draw the line between this මේව line එක draw කරන්න පුළුවන්. ඒ signal එක connect කරා. Right? So that is called Manchester. ඒතර මම මේක අඳින්න යන්නේ නැහැ. ඔයගලන්ට පුළුවන් මේ හැම එකකම මේ මැද පොඩි තිත් පෙලියක් වගේ දාගන්න නැත්නම් මේක අඳින්න අමාරු. දැන් මේ මෙන්න මේකේ දැන් අපි අඳිනවනම් 0 එක ඔන්න ඔහම ඇවිල්ලා ඔහම change වෙනවා. Right? ඔන්න ඔය විදිහට තමයි අඳින්න ඕනේ. Right? So it's better to have the lines between that. Okay. I want you to do this exercise. Encode the following byte values using NRZ L, NRZ I, and Manchester. So what are my values? First one, you get zeros. So, zeros, make ones, make 101. So make NRZ L ekedi metika komada represent when. NRZ I ekedi metuna komada represented. Manchester ke komada represent when nikila andela. I will put the Padlet link. Padlet link ekata. ඔගලන්ගේ answer එක photo එකක් විදිහට upload කරන්න. Right? Okay, start that. I will send the Padlet link through the chat. Chat එකෙන් මම දාන්නම් Padlet link එක. එතකොට ඒකට ඔයගොල්ලෝ photo එකක් ගහලා මේක after finishing everything you send me the answer. I got several answers. I will share that one. This is your answers. Okay, I will take one. So NRZ L, when you are taking NRZ L, so zeros you can represent as zero like the same line. Okay, this is correct. Ones you can like represent with like little bit line like this above the x-axis, also correct. Then 1 0 1 0, yes, right. So no need to so some of you have put another line x-axis. No need to put x-axis because this is bit different than this example, because I have taken x-axis here without taking the other line. So you have to draw like which I drew in on the board, right? Same way. So mathing x-axis then Manchester NRZ I inverted, zeros are same. When you get 1, it should change. I can't see it properly. I will see the other one. One you have to change. No, not like that. One should be changed like this. Once means they're changing the pattern. No? That means you are starting from 1. Oh, palhata ava. Again, another one can udatenawa. So when you get the 1, it is changing. Change karan. Something like this. That you have to change. 1 0 0 is not change again because of 1. It is okay. This is fine. Then Manchester, all are zeros. You have to draw the sets. You have to draw like this. Each part you have to draw the set like this. This is correct. Then you have to draw the line between them. Connect karan. Right? Connect karan. So 1 even you have to draw is S, something like this. Okay, then you have to connect this line. When my lines connect karan. then it is okay. Then 1 and 0, 1, 0, yes. This is okay. Whose one is this? කාගෙද මේ answer එක? මම පේන්නේ නැහැ කාගෙද කියලා.
සයිතුමාගේ.
Okay, I think you got that. Encoding. Okay, then we'll go to the other part. Take your books and write down. Error control. Topic. Error control. Now, when you are sending the data, you have to check whether there's an error when you are transmitting the data. So that is done by the error control. There are different ways, but we are discussing only parity check in your syllabus, right? Write down under that. And error control. During data transmission, sometimes data bits may get flipped due to various reasons. In such situations, data bit received is in error. Data bits received is in error. Error detection is the process of identifying that the data bit has been altered during transmission. Error correction and recovery mechanisms are used to correct the data bits received in error and to recover the actual data bits. So that's means like you are sending some data. Right? Right? So in this side 1 0 1 1 0 1 here, now this data bit has changed to this one. So that is totally error. So if you convert it to decimal, you are getting a different number. This is different numbers, right? So that is a total. That's a data transmission error, right? So we have to have a kind of a mechanism to identify them. Whether we have, when you are at least to identify there's an error in the data transmission. Even we can't find the what is the error, but there should be a mechanism to find out, okay, there's an error in data transmission, right? That's what you have to identify, right? So that can be done by using something called parity bit or parity check, right? There are different mechanisms. Checksum is there, AR model is there, different mechanisms are there, but in your syllabus we are talking about the parity check, right? So we'll write down on the parity check, write down the topic, parity check, parity check. Under that, write down this is one simple error detection this is one simple error detection mechanism where an extra bit is data is added and sent along with the original data bits to make number of ones in the data as either even in the case of even parity or odd in the case of odd parity Okay, I will show you now. We'll take the same data, right? We'll take the same data. Here I am adding another bit called parity bit. I'm taking another bit called parity bit there. Now I am after sending the bit. There also you get the parity bits. And my value I'll take 101100, right? This is my data, right? Okay, look at here. Right? Now, if I am using, there are two types. If I am using even parity, මම පාවිච්චි කරනවා even parity කියන එක. Even parity පාවිච්චි කරනවා නම් before I send the data, I have to check how many ones are there. මේක හරියට තේරුම් ගන්න. එක ඒවා කීයක් තියෙනවද කියලා තමයි check කරන්නේ. එක ඒවා කීයක් තියෙනවද 1 2 3, right? To make it a even number. දැන් අපි පාවිච්චි කරන even parity කියලා අපි මුලින්ම decide කරගෙන the other end. We can receiving end එකටත් අපි කියනවා අපි පාවිච්චි කරන්නේ we are using even parity කියලා තියෙන්නේ ඒගොල්ලෝ right එතකොට අපි even parity පාවිච්චි කරන්නේ then my original data how many ones are there කියලා මම check කරනවා 1 2 3 එහෙනම් to make it to a even number I am putting 1 එක කියලා දාලා මම මේක ඔන්න data එක transmit කරනවා කරාම මේ පැත්තට data transmit එක ඔහොම යනවා එහෙම ගියා නම් ප්‍රශ්නයක් නැහැ. හැබැයි හිතන්නකො මෙතන change වුණා කියලා අපි අර ඉස්සල්ලා වගේ we take 1 here. That means this 0 bit has changed when you are transmitting. Right? Then how many ones are there? 1, 2, 3, 4, 5. All together 5. මේ පැත්තේ තියෙන 1, 2, 3, 4. Now we have communicate with that device. We are using the even pattern. එහෙනම් එයාගේ පැත්තට ගියාම එයා check කරලා බලනවා how many ones are there. එතකොට එනවා 5. 5 is a odd number. But in our communication, we are using even parity, but we are getting 5 ones. That means there's error. Kira identify karaga. So that's how they identify error detected. Right here, this side, error detected. From this bit, error detect karagana because you get odd number of ones. Okay, odd number, but we are using even parity here. අපි even parity කියලා තියෙද්දි එයාගේ පැත්තේ ones දාන odd වෙච්ච ගමන් එයා දැනගන්නවා there's a problem, right? Take it down for the even parity කියන එකට පොඩ්ඩක් දාගන්න එක example කියලා. Okay, right. Now we'll see if I am using odd parity, කොහොමද මේක change වෙන්නේ කියලා. This is my original value. So I am using odd parity. And I'm receiving and even I am communicating, okay. Before I send the data, I'm telling, okay, I'm using the odd parity, right? Now here we are counting how many ones are there. Then බලන්න ones කීයද කියලා 1 2 3. So 3 is a odd number. එහෙනම් parity bit එක අපි මොකද කරන්නේ? Parity bit එක we are putting 0 because it is already odd number. එතකොට අපිට odd එකක් කරන්න දෙයක් නැහැ. Here suppose you have 4 ones කියලා දෙපණක් මෙතන තව එකක් දාලා 5 කියලා odd එකකට හදන්න. But here in our original data we have 3 ones. That means already it's odd. No need to put ones because you are counting only ones. ඒක මතක තියාගන්න. සමහර ළමයි මේක බිංදුව count කරලා එහෙම නෙවෙයි හැම වෙලේම ones තමයි count කරන්නේ. එතකොට 103යි කියන්නේ that is odd number. So you put 0 and send the data. එතකොට මෙතනත් ඔය විදිහටම data එක යනවා. Right? Suppose this bit is changed to 1. අනිවාර්යෙන්ම 1 or 0 0 1 ඔය විදිහට change වෙනවා. මෙහෙම change වෙච්ච ගමන් this is error කියලා detect කරනවා. Detected. Let's say because it's a even ones. ගානේ even වෙලා තියෙනවා. So from that one you are finding there's a error. So this is called odd parity. If you are using odd parity to send the same data, your parity bit is just like this, right? Okay, take it down for the odd parity. Odd parity akana metana you change it, so error can be detected by the odd parity even, right? Take it down also. Oh, Ashini, I will come to that part. Okay, right. Now here the problem is or even parity we can use, doesn't matter, we are detecting the errors. හිතන්න දැන් මෙතන මේ 0 එක මම change කරේ 1 එකට. මම මේ 0 එක 1 එකට change කරා. What has happened? මේ bit දෙකම change වෙලා when it is transmitted, right? Now here I'm using the odd parity, same thing. 3 ones, we are sending the data. Receiving end is for counted 1, 2, 3, 4, 5. He is also getting odd number. Yeah, count කරන්නේ how many ones කීයද කියලා නෙවෙයි මෙතන count වෙන්නේ, whether it's odd or even. 3 කියන්නේත් odd එකක්, එනම් 5 කියන්නේත් odd එකක්. So even data has changed, 2 bits has changed, this error cannot be detected by this method. So අපිට මේ parity check එකෙන් bit දෙකක් හෝ power of 2 දෙක හතර ඔය වගේ ගානක් වෙනස් වුණොත් we can't use this parity check to identify the error. That is the problem, right? So we write down. Ashini was asking that part. Okay, good. Write down new paragraph. If 2 bits are changing, if 2 bits or power of 2 changing, this method cannot be implement to detect the error. Right? New paragraph. Other than the parity check, there are some other type of error detection and correction methods. Such as in point form, write down කීපයක් අපි ලියාගමු. Automatic repeat request, ARQ කියලා. Automatic repeat request, ARQ. Another point, forward error correction. Another one, checksum method. Etc. Right? Okay, I will give you a small question from this parity one. Give me a second. Write down this question. First, you write down the question and send me the answers through the chat. So you have to send me the answer through the chat. So they're asking which one is incorrect. Read the question carefully. A, the B, the C, the Kela. Think and do that. First, you take it down. Then send me the answers through the chat. Try to find out. 3 binary numbers in the register A, B, C, and C have been transmitted from one computer to another. Register A, B, C, they have given. So one binary number has been transmitted incorrectly. This is Identify through the use of parity bit. Identify which register contains the binary number that has been transmitted incorrectly. Explain the reason for your choice, because now here two are transmitting correctly, one is incorrect. That one you have to find out, right? So okay, I will now only I'm getting some errors, answers, sorry, answers. Okay, most of you have put the correct answer. So how to find out here? What is the parity they are using? How many ones are there? 1, 2, 3. That is actually odd. Here 1, 2, 3, 4, 5. That is also 5. That is also odd. Here 1, 2, 3, 4. That is even. So in the question they are telling two registers are transmitting data properly. Can හරියට කරනවා කියන එකක් වැරදි. එනකොට එකක් හරි කියන්නේ these two are using odd නේ. odd දෙකක් තියෙනවා, even එකක් තියෙනවා. එහෙනම් අනිවාර්යයෙන් මොකද වෙන්න ඕනේ? එකක් වැරදියට කියන්නේ that is even එක use කරන එක, that is register C. මේක තමයි එහෙනම් answer එක, right? I will give you another small question. It's a bit different. Okay, try to do this one. No need to draw. You take a screenshot, doesn't matter. Mata hoyala kiyanna. Question, read the question carefully. You have to find out which number, column number, and the byte number. Read the question carefully. මේක එක bit එකයි error එකක තියෙන. ඒ bit එකයි හොයන්න යනවා. Now we are detecting the error. Error bit එකයි අපි හොයන්න යන්නේ. There's error කියලා කියනවා. එතකොට error එක අපි කොතනද තියෙන්නේ කියලා හොයාගන්නයි යන්නේ. Try to do that. And tell me the which column and which byte කියන answer එක මට send කරන්න through the chat. So they are telling flowchart, the word is transmitting, right? And they are using even parity. They are telling, question in the question they are given, they are using even parity. So this is the parity byte එක. Parity byte යවනවා, not only bit. Hey, අපිට ලොකු word එකක් නිසා we are sending that, right? So you have to find out where's the error. We බලාගෙන යමු. එහෙනම් column 1 එකේ කොහොමද ones ඒවා තියෙනවා? 1 2 3 4 5 6 7 8. එතන 8ක් තියෙනවා. even parity නේ. එහෙනම් මේක හරි වගේ අපිට දැනනවා නේද? Then මේ පැත්තට බලමු. මේක බිංදුව එකත් හරි. 1 2 3 4 5 6 7 8 9 10 එකත් හරි. මේ ඔක්කොම හරි. columns ටික බලාගෙන යද්දි 1 2 3 4 මේකත් හරි. 1 2 3 4 මේකත් හරි. 1 2 3 4 5 6 7 අන්න මෙතන වඩා අවුලක් තියෙනවා කියලා ඔන්න අපි first we are finding the column එක හොයාගත්තා. 1 2 3 4 5 මේ 6 එක හරි. 1 2 3 4 එකත් හරි. එහෙනම් මෙතන column 6 එක හොයාගත්තා. Then you have to find out the other way. That is a row. 1 2 3 4 මේක හරි. Because it is even. They have given even parity. කියන එක question එකේ දීලා තියෙනවා. 1 2 3 4 එකත් හරි. 1 2 3 4 5 6. 1 2 3 4 5 6. 1 2 3 4. 1 2 1 2. Something like 1 2, 3. Here 1, 2, 3. Now මෙතන පොඩි අවුලක් තියෙනවා කියලා හොයාගත්තා. Again 1, 2, 3, 4. එකත් හරි. 1, 2, 3, 4. This is also correct, right? So odd එකක් ආවේ මේකේ. Right? එහෙනම් what we have to do? අපි බලන්න ඕනේ මේ දෙක intersect වෙන්නේ කොහෙද කියලා. Where it is intersecting. එහෙනම් byte 7 එකේ එකයි column 6 එකයි කියන්නේ මෙන්න මෙයා තමයි. This is the answer. That means we have write down the column 6 and byte 7. මෙන්න මෙයා තමයි error විදිහට transmit වෙලා තියෙන්නේ, right? So I think you can understand that one. Some of you have put the correct answer. Answer හරියට දාලා තිබ්බා, right? Okay, right? So this type of questions can come. මේක අලුත් part එකක් මේවා ඔක්කොම 2019 වල add වෙච්ච ඒවා encoding and all this stuff. එතකොට sometimes you are getting the question from this part, right? Okay, so we'll finish for the day. Next week we'll continue this one. Okay, thank you. Have a nice day.